Alright, so we started the unit basically talking about explanatory and response variables. When it comes to two different variables, we're trying to see if there's a relationship between. So in number 1, parts A, B, and C, you were supposed to look at the two variables that were given. So we have baking time and we have an oven temperature. And you have to determine which one is the explanatory and which one's the response. So remember that explanatory is the variable that basically comes first. It's what we think will influence the other one to happen. So between baking time and oven temperature, hopefully you put oven temperature because that will influence how long something takes to bake. So for the explanatory, put oven temp, and then baking time would be the response. Alright, and then for part B, how often does a plant, or how often a plant is watered and the plant height. So our two variables there are how often the plant's watered and the plant height. So once again, think about which one kind of has to come first in order to have an influence on the other. So the watering of the plant has to come first because then the plant will grow. So how often the plant is watered would be the explanatory variable. I'm just going to put how often it's watered. And then plant height, excuse my chicken scratch, hopefully you're just checking your answers, is your response. Alright, and then on C, how large students write their name is one variable. And then their grade in science class, that's the second variable. So hopefully you realize that no matter how big you write your name in science on your papers, your grade isn't going to necessarily depend on that, rely on that, be influenced by that. So there really is not an explanatory or response variable in this case because your size of your handwriting does not influence your grade. So we can write NA like it instructs us to do if there's not necessarily a relationship that's obvious that we would think influences, where one variable influences the other. And then on number 2, it asks for the 4 traits of the scatter plot. Remember that's the acronym DOFS, where D stands for direction. You have to actually list them, you can't just put DOFS. O represents outliers. F represents form. And then S represents strength. So those are the 4 characteristics that you have to discuss when you talk about scatter plots. Number 3, you're naming the form. So remember the form is one of the characteristics, and that's what kind of trend overall you're seeing, basically what kind of function you're seeing overall. So notice this one here is kind of like a U shape. So that was quadratic. So hopefully that one was quadratic. If you see basically nothing going on, that is no correlation, there's no pattern there. And then notice here we have this kind of going up, dips down, comes back up. That's an obvious cubic. Don't force a cubic. Like in this next one, the overall trend is linear. So notice I kind of drew boundary lines, that helps. And then the overall trend on this one, notice it's going down and it kind of flattens out here. That is exponential. If it dipped back up, then it would be quadratic, but it doesn't dip back up. Exponential flattens out. So hopefully you were able to name those forms. If not, look back at that PowerPoint. Alright, so on number 4, it asks us to compare the strength of these two scatter plots. And it's asking what is the point the teacher is trying to make by giving these graphs. So we had a very similar situation on in the class discussion in a PowerPoint. Notice here they basically look like they're the same form. Notice it has like this similar shape. So if you trace them, they have this similar shape. If you look closely, you should notice this one's counting up by 10 each time. This one's counting by 20. So even on the Y scale, this one's counting by 10s, and then this one's counting by 20s. So basically, one scale is more zoomed in than the other, and if you really look at it, they're the exact same graph, one's just zoomed in. So that's why we can't use our basically naked eye to judge the strength of the correlation, because it could just simply look like the points are more together if it's zoomed in. Well, if it's the exact same coordinates, if it's zoomed in or zoomed out, it's the exact same strength. It's just one is zoomed in. So in this case, we would put something like the strengths are the same because it's the same graph. One's just zoomed in. Alright, so something like that. Excuse my loud tapping. I guess I write hard. Didn't think I would, but I guess I do. So it's the same graph, one's just zoomed in. Alright, so something like that should have been fine. If you put that, you know, the second graph is more strong, that's wrong because they're the same graphs. Alright, so now let's go ahead and look at number 5. So number 5, you had to actually go through and make some a scatter plot. It gives you some data. So the very first thing you should be thinking is which one should go in your L1 and your L2 when you're going to make a graph. So just reading some of the information can help. Notice it says a food industry group asked 3,368 people to guess the number of calories in each of several common foods. And they give us a table of their guesses and their correct number of calories. Notice here it says we think, says here, oops, that is definitely a pin mark. I'm trying to highlight it here. So we think how many calories a food actually has helps explain people's guesses. So basically they're saying right there that they think the actual amount of calories, the correct calories, helps explain the guessed calories. So that means they're thinking that this here is our L1, our explanatory variable. They think it explains L2, which is our response variable. So we definitely want to realize if they think that this is explanatory, it needs to go in L1. Explanatory always goes on your x-axis. That's why we need to put in L1. And a little messy there. Alright, explanatory. Okay, and this is our response. Alright, so we want to go ahead and put this data in our L1. So I'm just going to go to my calculator over here on the right. And I'm going to go to stats, I'm going to go to enter on edit, and now I'm just going to enter the numbers for correct calories first in L1. Notice if you would have just put it in order as the table looks, your order would have been wrong, and a lot of things would have been wrong. Your line of best fit would have been wrong. The only thing that would have remained is your R value, because the strength is not going to judge which one is in, I mean if your variables are in the right order, so. Alright, so I'm just punching in the data. Alright, and notice we need to put the second set of data, which in this case is the guess calories, into L2. So, do that really quickly. If you feel like you don't have enough practice with running the calculator steps, you might want to just hit pause and you go ahead and enter it too and see how much of the steps you can do without hitting play again. Alright, so I'm just going to glance over my data and compare the list with the original list and make sure I didn't forget a digit somewhere, because that can really hurt everything. Everything will change based off of that. So for instance, it's good I looked at it, because if I look at what I have highlighted here, I put in 393 when it should be 394. So that allows me to just kind of check and fix anything that I may have punched in wrong, because obviously punching in fast can cause problems. Alright, and everything else looks good. Okay, so just remember we need to make a graph. So in order to make a graph, we're going to do the same thing we did in every other unit, and we're going to go to second, y equals. We're going to turn our stat plot 1 on. So we're going to hit enter and then enter again. Now it's on, but we need to see the graph, so we're going to hit zoom 9. If you're using the app, you're going to hit graph, and then in the bottom corner you'll hit zoom and then zoom stat. Alright, so this is my graph. So in order to actually display what we see, there's a few things required in order to make it to where it gets full credit. So the first thing is we need to draw just the general trend that we see. So I'm just going to make the points how I see them. They don't have to be precise, but I'm just kind of dotting how it looks to me, just in similar fashion. So that's what I see. Now, you also need to label your axes. So notice we put the L1 was the correct calories. So I need to label correct calories on my x-axis, and then guessed calories was on my y-axis. So I'm going to move explanatory so I can put some writing there. And since I'm left-handed, it's just going to be easier for me to write it this way. Alright, so that's the guessed calories. You also need to mark the minimum, the most left point tick mark, and the most right point tick mark. And the same thing, so your min and max will be on your x, and you got to mark your min and max is going to be on your y. So notice I'm just marking the lowest and the highest, and then the most left point and the most right point. Now I actually have to find the numbers for those. So in order to do that, remember the easiest way is to do the 2-bar stat in your calculator. So you're going to go to stat, you're going to go over to calc, and you're going to go down to number 2, which is 2 variable statistics. So we hit enter, and we want it to go ahead and calculate it for us. So you just hit enter if you have the other screen, and go down and calculate like I did. And then, oh, my fault, I hit a button, so let me go back to where I was. Calc, 2-bar stat, enter. Alright, so now if I scroll down, you'll see the min and max for the x-axis and the min and max for your y-axis. So my min and max for the x-axis is there at the bottom right now, and I see 12, and I see 269. So you want to make sure you put those min and maxes to get full credit. And then the same thing for the y, I see 74. And I see 419. So I'll try to squeeze that in there. Alright, so that's my min and max on each axis. And then lastly, if you want to get complete full credit, because right now it's only 3 out of 4 points would be given to this graph, we need a title. So we can just put correct calories versus guessed calories or something like that. So correct versus guessed calories is fine. Alright, hopefully it looks neater than mine, but it's kind of hard to use this little stylus. Okay, so now you want the equation of the line of best fit. So next you should have went to stat, went over to calc, and you want to go to linreg a plus bx. That's going to give you the line of best fit. But just so I show you something here, because notice we're also going to need the correlation coefficient, which is the R value. Remember, that just means the R value. So we're going to need that. But notice if you go to linreg a plus bx in the calculator here, and you just go to calculate, it's only going to give you your a and your b for your equation. It's not going to give you the R. So in order for that R to show up, you need to do the turn your diagnostic on. So to turn your diagnostic on, we're going to go to second 0, and you're going to go down to, instead of having to scroll down like forever to get to diagnostic on, you could just hit x to the negative 1 power, which is red on my screen right now, and you scroll down to diagnostic on, and you want to hit enter, and hit enter again. You should see the word done. Now that it ran the diagnostic, now when you do that stat over to calc and you go to that linreg a plus bx, now underneath your a and your b will show your R value. So there we go. So now we have our equation and we have our R value. So to write your equation, you want to just follow the pattern that you see there, which in the screen you see the y equals a plus bx. So we're going to do y. And really, you should be putting a little hat over it, and I'll kind of say why once we start the next part of the unit. But y equals a. Now the a value is 58.587, so I'm just going to round to 2 decimal places. So 58.59. So notice the format. I'll just write the format up here. Y equals a plus bx. So I'm just substituting in the numbers. That was my a. Now I'm putting plus. If my b was negative, I would just put minus as my negative. But it's positive 1.30. And then don't forget to put the x by the b. So that is my answer for the line of best fit, which is also called the least square regression line. Alright, so that's my equation. Now we want the R value for part B, and the R value is in our screen. We know that R is equal to, remember the name of R value is correlation coefficient, so don't let that scare you. Whenever you see that, that's just the R value. So R equals 0.82. And then now we need to describe the relationship in context. So remember, to describe, you need to include all 4 characteristics. So it might be wise for you to just kind of make an outline out to the side. Remember, that's the DOFs. So the direct DOFS. So if you make a quick little outline, then you'll kind of know what to put in your sentence. So you know your direction of the graph overall. So if I kind of just highlight these points here, the direction we're seeing is positive direction because it's going up from left to right. So I know I'm going to say it's positive. Any obvious outliers? Well, if you want to, let's see if I can erase this without, erase all my yellow really quick. If you want to see, you know, you want to judge better if there's outliers, you can go back to your calculator. Remember, you can put the line in the graph. And to do that, I'm going to stat, over to calc, going back to that linreg, a plus bx. I'm hitting too many buttons, sorry. Using my thumb. Okay, so I'm going back to number 8. Now, when I do that, if you have the other screen where you just have a little cursor, then you're going to put a little Y1 where your cursor is. If you have this screen that you see on my screen, you're going to put your cursor there, and then you're going to put your Y1. So no matter which screen you have, you don't want to hit enter right away. You want to put a Y1 where your cursor is. So to get the Y1 there, you go to vars, you arrow over to the right to Y vars. Then you hit enter twice because you want to hit enter on function and enter on Y1. So it puts a Y1 there. So now when you go down to calculate, it didn't do anything new here, but when you hit your graph, you'll see a line go through your actual, your graph, your scatter plot. So when you're looking for outliers, you basically want to see, is there any point that is pretty far from the line? So if you look here, these 2 points are close to the line. Even though they're kind of far away from the group down here, they're still close to the line, so they're not considered outliers. This is pretty close. These are really close. Now these, you may think, oh yeah, those are kind of far. They're far in comparison to the rest, but are they really that far? I mean, if you want to say 2 possible outliers, you can, but really when I think of an outlier, I think of something like all the way over here, to where the distance from the point to the line is very far. Or it could be something really much far down here, to where the distance to the line would be pretty far. In all reality, that's really not that far there. Alright, so I mean, if someone put 2 possible outliers, I would take it, but I would probably say no possible outliers, or no obvious outliers would probably be better. They're not really obvious outliers. Switch my pen over. Okay, so I'm going to put none. This is just my little outline over here on the bottom left. Form, definitely looking linear. Most of our stuff will be linear in this unit, unless it's like the problem at the top of the page where it's just kind of like naming the forms. Now strength. Remember, your strength has to be based off of the R value. So if you go back to the PowerPoint where I showed that the R has to go, the R value is only going to be from -1 to 1, where 0 is no correlation at all. But then we have some cutoffs. So we have the 0.5 cutoff. It'd be hard to write it small here. We have a 0.8 cutoff, and we have a 0.9 cutoff. So within those ranges, and it's the same as on the negative side. So I'm just going to really focus on the positive side. So in here would be weak. That'd be our weak. Now, of course, it's on the positive side, so it'd be weak positive. If it's from 0.5 to 0.8, that'd be moderately strong. So I'm going to just put mod strong. So moderately strong, that means kind of strong. If you have a value in between 0.8 and 0.9, so in there, that would definitely be strong. And if you have a value in between 0.9 and 1, that is very strong. So when you're explaining the strength, you need to look at that R value and think about where it would be. Well, 0.82 would definitely be between 0.8 and 0.9. So that would be strong. So use that number line to describe the strength. Don't just guess, but go based off of what you think. That's not what statisticians get paid to do. They don't get paid to guess. Alright, so now you just put it in context. And context means you have to mention the variables. So you can say something like, there's there's a strong, I'm going to just put it all together, positive linear relationship, I could say correlation if you like, between, now I'm going to name my variables, correct calories and guessed calories with no possible outliers, or with no obvious outliers. Then maybe they're possibly outliers. So with no obvious outliers. So that's everything summed up in one sentence. If you wanted to separate it and write in two, that's fine. Once again, sorry for the chicken scratch. Alright, so I'm just moving that so there's a little room for the sentence there. Alright, so that is number 5. So hopefully you were able to answer that stuff there. Alright, so now number 6 and 7. Let me see if I got 6 here. Okay, so here's 6. So 6 is very similar. You put the data in the calculator, you make the scatter plot, and you describe it in context. So let's see. If we want the gas mileage of an automobile, first increases and then decreases as the speed increases. So suppose the relationship is very regular, shown by the following data on speed and mileage. So we want to make a scatter plot, draw the sketch, and describe the relationship. So I'm going to go ahead and do that here. So I'm going to go to clear my calculator first. So I'm going to go to second plus 712. So I reset, clear my calculator. I'm going to go to stat, edit, and we're looking at speed and MPG, which is miles per hour. No, I'm lying. That's miles per gallon. So miles per gallon is basically how much gas you're getting, how well your car is doing on gas. So we can go ahead and put speed as our L1 because we're thinking that our speed is going to influence the amount of gas we're either using or how well our gas is doing. So I'm going to leave it in this order. Alright, and then we're going to go ahead and type in that data, and hopefully you already did this, but I need to get on my calculator. Alright, so once again you can pause if you want to, and then try to get through all the calculator steps and see if you get the same graph, just to make sure you can run through it. Alright, so I put in my data. I'm just going to do a quick look at it, make sure it looks good. I didn't forget any digits. Okay, so I'm going to make my scatter plot. So I'm going to go to second y equals. I'm going to turn that stat plot on. Remember, it's default on scatter plot here, so you don't have to change anything, but we do have to do zoom 9 so it'll actually zoom correctly. And I can go ahead and just start plotting what I see. So I'm seeing a relationship that looks kind of like this. And remember, just the points alone will not give you full credit. It'll give you 1 out of 4 points. You don't want that. So you want to remember mark your min and max for each axis. We're going to have to find those numbers. And we're going to name our axes. So we put an L1, which was our x value, we put speed. And then for L2, we put MPG. Ooh, that's a terrible M, but I promise it's an M. Alright, so we put MPG. So now to get my min and max, remember we can go do the 2-var variable stat. So edit, over to calc, 2-var stat, enter, go ahead and calculate. And I'm going to scroll down so I can see my min and max on my x-axis is 20 and 60. And then if I scroll down to my y, I see 24 and 30. And I just need a title, so I can put speed, just keep it real simple, speed versus MPG. Alright, and now I just need to describe the relationship in context. So, remember our relationship characteristics are DOFS. So direction. Well, it told us in the description there that it first increases and then it decreases. So I kind of know here that we have a positive, it starts off positive and then it goes to a negative relationship. So I'm just going to put that here, starts positive, then negative. Alright, outliers. Well, I don't see any obvious outliers because if you notice here, our form is quadratic. So I'm going to put that here. Outlier is none. I'm just going to put none there. And for the strength. Now, remember the R value is just for a linear regression. So you don't want to go to stat, calc, and do a linear regression when this is a quadratic. Now, yeah, you may see quadratic regression there, but notice even if you ran it, there's no R value. No R value, even if you turn your diagnostic on. So I'm just doing it really fast to show you. That R value is only for a linear relationship. So any relationship that's not linear, you basically just kind of have to say how closely it follows that trend. So that's one of those where you're just going to estimate, you know, how it looks close to it. So I'm just showing if you ran a quad regression, you're not going to get an R value. You get R squared, which that's a whole nother day talking about what that is. Alright, so you don't describe the strength based off an R value unless it's linear. So here you would just say that it follows, the data follows a quadratic form or something like that, or it's very close. It appears to be a very strong quadratic relationship or something. So here's the time where you can go based off appearance, but you want to mention something like that. It appears to be a strong relationship. So that way we know by using that word appears, you didn't necessarily use an R value. So putting it all together and in context, we could say that there's a, or there appears to be a strong quadratic relationship between we got speed and miles per gallon. And we can now describe the direction because I didn't get the direction in there yet. But remember, you could do this in 2 sentences. You could do it in word it your own way. It's not going to be worded the same way as I'm wording it, but as long as you're including all 4 characteristics. Where it increases first and then decreases. And then I'm going to say with no obvious outliers. And if you, like I said, you could split it up into 2 sentences if you want. Alright, so that's everything. Once again, I apologize, it's chicken scratch. Hopefully me saying it helps. But all I did there was I identified the 4 characteristics and I put it in a sentence. So that's what I'm looking for. Did you identify the 4 characteristics and put it in context? Alright, so that was number 6. Then number 7. Here they're asking for the explanatory and response variable based off the graph. I'm just basically assessing you on whether or not you know that the explanatory is always found on the x-axis. So our explanatory variable there is average daily temp. And then the response variable will always be on your y, so that is visitors. I'm going to put number of visitors. You can even put beach visitors if you like. And then C says finish the statement. So as the average daily temperature increases, so basically as we go this way, because that's how the temperature increases there, as we go this way, what happens to the graph? Well, the number of visitors increase. So the number of visitors increase. Alright. So now, looking at number 8. So number 8 tells you to choose a scatter plot that best represents the relationship between age of a car and the amount of money spent each year on repairs. So I would hope when you first buy a car that if it's a brand new car, because we're talking about the age of the car, not from when you bought it, but if it's a brand new car, freshly made in 2021, then we would hope you wouldn't have to take it for any repairs for a while. But as the years go on, you may have a repair here, then more years go on, you may have 2 repairs that year, it goes on, gets older, may have 5 repairs the next year. So as time goes on, we would expect the number of repairs to actually increase. So as the age increases, and I'm just going to point to all the x-axes here, as the age increases, we would expect the graph to actually go down, to go up. So the number of repairs would actually increase. So notice that would only be this graph as an option or this one. So we can say why it's not C. So it's not C because the older the car gets, we would expect the repairs to increase. Alright, so now we're down to graph A or graph B. So there's a huge difference between graph A and graph B. So notice it's really your x-axis. You have negatives on your x-axis on graph A. And remember, we're talking about the age of a car. You can't really be a negative amount of years old. So it can't be graph A because the age of a car can't be negative. Alright, so I'm just saying why it's not each. Because notice it says explain why you chose your answer. So that's why it's definitely B. So me explaining why it's not the other two is the same thing as explaining why I'm choosing my answer. Alright, because I'm basically saying why it can't be the others. So as long as you did something like that. If you just said it's graph B because it's increasing, well then I'm going to say, well then why isn't it graph A? So if you're identifying, yeah, it's increasing, sure, you also have to include why it can't be A because A is also increasing. So you could have did something like it's graph B because it's showing an increase and we expect the number of repairs to increase as the age of the car increases, while graph A is doing that, it also has a negative age, which we can't have. There's no such thing. So that is number 7 and 8. And then lastly, is that it? I can't see it. I don't think that's it. Hold on. Alright. Okay, here we go. Our last question. So our last question, number 9, don't need a calculator for, but so I'll just keep that minimized there, but we have to put it in order, the graphs in order from weakest to strongest. So remember the weaker graphs are more scattered and the stronger graphs are more together in a form. So if I wanted to go through and see which one's weakest and strongest, it might be a good idea for me to create like border lines, so boundary lines. So if I kind of create these boundaries here, it'll show me how wide these coordinates are spread out. So it'll help kind of guide my thinking. Now I'm just kind of noticing if it's positive trend, negative trend, and then I'm bounding it by that. Oops, that one's way too close. I'm actually going on the coordinates. Alright, so most of them are obvious, except for a lot of students have trouble deciding between A and C. So making the boundary lines will kind of help you see that the widths are a little different. So the widest one is your weakest, which is C, and then A is the next, and then it goes to D, getting stronger, and then B is the most strong. So hopefully put your order that way. If not, try using the boundary lines. It helps. Alright, feel free to let me know what questions you have right before we start the quiz.